So here we want to find the sum, but as you can see, we have sigma notation. This is sigma notation. What this tells us is find the sum of 5 terms starting at the third term, and the rule is 1 over j. So we do 1 over 3, because it's at j equals 3 for the first, and this is terms 3 through 5 that we're trying to find. 1 over 4 and 1 over 5. This is the number of terms that we're allowed to find. And it's 5, but we're starting at term 3, and we're going to find the sum. And the rule is 1 over j. So 1 over 3 plus 1 over 4 plus 1 over 5. We find the least common denominator for 3, 4, and 5 and add them, and we get 39 equals 50. Now we have another one just like it, and it's find the sum of the first 5 terms where j equals b, and the rule is 1 over b. Sorry, where j equals 3, and the rule is 1 over b. So since it's b, it's just going to be over the first 5 terms, starting at the third term, just like here, except it's going to be 1 over b plus 1 over b plus 1 over b, which equals 3 over b. So that one's a little easier because we don't have to add fractions because it's just over b every time, because we can't use a 3 because the rule is 1 over b. Here we're working backwards. We need to write the sum using sigma notation. So we're going to write the sum of 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third plus 5 to the third. So it's going to be the sum of 5 terms, because that's how many terms there are, 5 terms, where the first one equals 1 to the third, and the rule is j plus 1. So here we have a graph of a parabola, and we want to write the equation. And we want to write the equation of this graph. So we're going to use the standard form of a quadratic formula, which is y equals a times x minus x1 times x minus x2. So first we need to find our x-intercepts. Our x-intercepts are -5 and 4. Those are our x-intercepts. So we're going to rewrite this now as y equals a times x minus our first x-intercept, but we do the opposite of what it is. So if it's negative, we make it positive, plus 5 times x minus 4. But now we need to find what a is. We know that a tells us whether the parabola opens upwards or downwards. So the one thing we know about a is it's going to be greater than 0 before we find what it is. In order to find a, we need to plug in a point for y and for x. So what we can plug in for them is our remaining point, which is 3, -6. So we get -6 equals a times 3 plus 5 times 3 minus 4. So 3 plus 5 is 8. 3 minus 4 is -1. So we get -6 equals a times -8. Divide -8. Divide both sides by -8. So a equals 3/4. So the way we would write our final equation would be y equals 3/4 times x plus 5 times x minus 4. This is solved by completing the square. We have x squared minus 12x plus 44 equals y is our quadratic formula. First thing we want to do is set y to 0. So we get x squared minus 12x plus 44 equals 0. Then we take anything on the left that doesn't have a variable in it, which is 44, and move it over to the right. So we get x squared minus 12x equals -44. Then we add b over 2 squared to both sides. In this case, b is -12, so over 2 squared is 36. So we get x squared minus 12x plus 36 equals negative 8. Then the reason we did this is so that our left side is now a perfect square, which is x minus 6 squared equals negative 8. Then we take the square root of both sides, and we get x minus 6 equals plus or minus the square root of negative 8. And since the square root of any negative number is just, like if this was 8, for example, this would be rad 4 times rad 2, which would be 2 rad 2. Since it's a negative, we have to put an I next to it. So instead, it's 2I, which lets us know that we're breaking up the square root of a negative number, rad 2. So it's x minus 6 equals plus or minus 2I rad 2. So it's x equals 6 plus or minus 2I rad 2 is our final answer.